Hi, this is video 2.1, classifying rational numbers. Remember, because these are Cornell style notes, you are going to divide your paper into these 4 quadrants: title, date, keep a section for those questions. Remember, you're going to be typing in questions into the video. And then our CPQ this time, our question: how can you classify rational numbers? And when they say classify, that means that you're going to, it's like sort them into groups or into categories. We're going to look first at rational numbers and the definition of a rational number. A rational number is any number that can be written as a fraction where a and b are integers and b is not 0. So what they're saying is that you have to have an integer in the numerator. What's an integer? An integer is like a number, just a plain like whole number, or a negative. It's opposite, a negative whole number. Okay, but you can't have 0 in the denominator. So if you have something like this, okay, that you can't have that. That's an irrational number. Okay, so you cannot have a fraction with 0 in the denominator. Okay, and a rational number, it can be a fraction, it can be a decimal, it can be a negative number, it can be a positive number, but the denominator cannot be a 0. Okay, so in these directions, I'm just going to review this with you very quickly because you learned this in elementary school. Write each rational number as a over b or as a fraction. So when I look at a, let me zoom in a little bit. I look at a, that's 3 2/5. Remember how you are supposed to multiply the denominator times the whole number and then add the numerator. So 5 times 3 is 15 plus 2, that's 17 over 5. I've heard different students come to Travis with different methods about that. They'll say sometimes that it's the backwards C. Okay, the backwards C. It's not really backwards, but you draw it backwards. Or the big C. No, that's what they say. They say it's the big C. Some students say that you get mad. You multiply, you add next, multiply, add, and then your denominator stays the same. Okay. Alrighty, 6/10. So we're going to write that as a fraction. I have a little trick for that also, if you want to know it. Just put a 1 under the decimal and a 0 under all the numbers after it, which there's only 1. And that ended up being a 10. And then just draw your fraction bar in between them, 6/10. If you had 235 thousandths, okay, just put a 1 under the decimal and zeros under all those numbers. Okay, so there's your numerator, there's your denominator, just put a fraction bar in between and there's your fraction. Okay. Anytime you have a whole number and you want to change it to a fraction, all you have to do is put a 1 in the denominator. Okay, when you look over here, they changed it from 32 to 34. So they made a little typo in the book, right? But it doesn't matter. All you do is just put a 1 in the denominator. Okay? If it's a negative number, same thing, just put a 1 in the denominator. Just like that. What I want you to do now is write down numbers 3, 4, 5, and 6 in your notes. And let's change these. You'll write -15 equals, and then let's just change them to a fraction. That's what that's saying. So that would be -15 over 1. Remember, it's just a number, like a whole number, except it's negative. And to change it to a fraction, you just put a 1 in the denominator. On this, we're going to get mad, the big C. So 9 times 4 is 36. 36 plus 5 is 36, 41. Here's the bell. 41 over 9. Okay, your denominator stays the same. You multiply, you add, and then the denominator stays the same. Okay, let's use our little trick for number 4. Put a 1 under the decimal, zeros under the other numbers, and there's your denominator. Just draw your fraction bar, and that's 31 hundredths. And then 62 is going to be 62 over 1. Okay, this would be a good time to ask you some questions about these. I'm going to give you some of these examples, and you can put the answers in your notes, in your questions, in your little quiz. Okay, for classifying rational numbers, this is something that you're going to see quite often, and it's the Venn diagram. And usually we see a Venn diagram that looks like this. And whatever it is that the two things have in common would be here in the middle, like that, in there. And this kind of a Venn diagram, it's still called a Venn diagram, but it's comparing three things. And what it's saying is that the big circle represents your rational numbers. So everything inside the big circle is a rational number. That means that you also have integers that are rational numbers, and you also have whole numbers. Whole numbers are rational numbers. Okay, now when I look at this Venn diagram, my whole numbers is in the very middle, and on the outside of it is integers. That means that all your whole numbers are also classified as integers, but not all of your integers are classified as whole numbers. Okay, so when we investigate types of numbers down here, we have some examples with actual numbers. For instance, the number 75. It is a whole number. Remember, your whole numbers are just your plain numbers. You start at 0 with the whole numbers. They say you start with the whole, like 0 is a whole, like a hole that you would go down into. Okay, so 0 through infinity. Those are your whole numbers, and there aren't any decimals and there's not any fractions. They're just numbers. And then your integers are those same numbers, but then they're opposites, or the negatives of those. So 75 is a whole number. It is also an integer. And then negative, let's say negative 75, it's not a whole number, because remember, your whole numbers start with the whole, with 0. But it is an integer. Okay? It's also a rational number, because rational numbers are all those whole numbers, 0 through infinity, and the integers, all of those numbers in the opposites. And then rational numbers include fractions and decimals. Okay? So if it's a decimal, it's not an integer, and it's not a whole number. It's just a rational number. Okay? If it's 75, it is a whole number, it's also an integer, and it's also a rational number. Okay? I kind of forget that you guys can see me. I'm all scratching my ear and stuff. Okay, I got frozen down there. Let's look at number 7. Name 2 integers that are not also whole numbers. Okay, so I don't want to give it a number that's 0 through infinity, because that would be a whole number. So I'm going to give it a negative number, because negative numbers are less than 0. So negative 5. Negative 5 is not a whole number. Okay? So for the piece up here that says your turn, we're going to classify each of those numbers. So what I would like for you to do is copy down this Venn diagram just like that. And we're going to take number 9, 10, 11, and 12, and we're going to put them inside the Venn diagram. So pause the video and go ahead and copy down that Venn diagram just like it is. Make it big enough to write numbers in. Okay, pause if you need to. Number 9, 14.1. We can't say it's a whole number because it's a decimal. And whole numbers are just those natural 0 through infinity numbers. We can't say it's an integer because integers are those 0 through infinity and then all those numbers as a negative. Those are the integers. So it would be a rational number. If it's a fraction or a decimal, it's automatically a rational number. 7 1/5. Remember I said if it's a fraction or a decimal, it's automatically a rational number. 7 1/5. And then -8. It's not a whole number because whole numbers begin with the whole, 0. So it's like a whole number but a negative, so it's going to be classified as an integer. Okay? And that would also make it a rational number. Remember, integers are inside the circle of rational numbers, so integers are also rational numbers. And then 101. That's a positive number. That is not a fraction or a decimal, so it's a whole number. And it makes it also an integer, and it also makes it a rational number because the whole number circle is inside the integers and inside the rational numbers. Now let's revisit our essential question, or this is our CPQ. How is a rational number that's not an integer different from a rational number that is an integer? Okay, how is a rational number that's not an integer different from a rational number that is an integer? Okay, and we would say that that's not an integer. It would be, let's say, and you want to write these down in your notes, a rational number that's different from an integer would be a positive or negative fraction or decimal. Okay, now let's get ready to do our Kahoot, and you can watch this brain break that I have for you at the end of the video.